At this point, I thought that it would be a good idea to fill in the circuit board where it burnt down into the board a little bit so that I could even it out, level it. I ended up having trouble getting the chip to seat and soldered all the pads because the added thickness of the wire on top of the solder mask was holding the chip up too high. Later on, I ended up digging that back out and just allowing the wire to kind of sit down into the recessed areas of the board. I accidentally cured some solder mask over two of the pads nearby where I was working, so now I end up spending some time trying to remove that. I'm missing some footage here. I went ahead and applied some more solder mask and cured it. Ended up scraping some back to expose more of the traces so that I could solder my jumper wires on a little bit better. Right now I'm tinning the traces with solder to try to prepare them for the jumper wires. I purchased some various sized pads that are pre-made for the repair, thinking that it would work. I looked at them and I thought, how am I going to put these on? These are so small. But if you look, they're even way too big at that size. And I found that I couldn't really bend the lead around easily, so I ended up abandoning that and not using the pre-made pads. I ended up getting solder in some places where I didn't want to, so now I'm spending some time going back and cleaning up. I didn't have any small jumper wire currently because I've never repaired traces on this microscopic level to date. This is the first time for me. I ended up taking individual strands out of solder braid, and that's what I'm using here. I did order some 0.1 millimeter enamel covered wire or coated wire that I will use next time, but this did work in a jam for me. This turned out to be very difficult for me, and it took me quite a while to get these two jumpers positioned where I wanted them. I definitely need to do this more to develop the muscle memory and eye-hand coordination. I mentioned earlier that I ended up having an issue with the IC chip not wanting to sit down and make connection to all of the solder pads, and it was because the jumpers being up on top of that solder mask were a little bit too thick and kind of holding the IC chip up. So later on I ended up digging the solder mask back out and just not even using it. I'm not sure if I have that footage. All right, now I began preparing the P13 USB chip for installation, just applying flux, going around and soldering each pad. I like to tin each of the pins multiple times because there's really not a lot of real estate to get solder attachment points. The pads are kind of small compared to some of the other IC chips like the M92 and the BQ on the bottom side. I believe this is a contributing factor to the difficulty I have of getting each pin to connect on this IC chip. Cleaning up the IC chip with some isopropyl alcohol here. Of course, I didn't get it in frame when I was videoing it. Placement of the IC chip is important. We have to make sure we get pin 1 in the right location. The dot for pin 1 indication is in the upper right hand corner of the chip, and it corresponds to the golden triangle on the motherboard off a little bit in the distance on the upper right. I'm hitting this with quite a lot of heat, probably around 450 Celsius if I remember correctly, and as low as airflow as I can get by with. The heat from the hot air station loosened up my jumper wires, so now I have to go back and redo those. I probably would have been better off installing the jumper wires after the rest of the chip has been soldered in place. I don't know though, I haven't tried it. I think it would work. Now I'm just going around touching up each solder joint individually and clearing out solder bridges that I created along the way, applying flux and cleaning as I go. The few times that I've replaced this IC chip so far, I've had difficulty getting every pad to connect. I don't know what it is about this IC chip. For me, it doesn't want to sit down perfectly flat with the chip installed to the motherboard. I'll do a diode check reading on each pad to the IC chip at the motherboard, and if it's connected to the pin, I'll see a reading generally of 0.3 to 0.7, whatever the known good value is at that pin. If the pad is not soldered well to the pin, I'll get an open line reading or something way out of range. Alright, I've pulled the filter off a donor board. May it rest in peace. I hate that I couldn't fix that one, but at least I'm able to use some components. I had a lot of trouble. Of course, out of all of the filters, it would have to be the very tiniest one that fried. These charred and missing pads just did not want to take solder. Yeah, it took several passes until I finally started making some progress. Getting the super tiny jumper wires bent around exactly where I needed them was a real challenge as well. I should have probably left this section out of the video footage because my performance here is just embarrassingly bad. Nothing was going right. I couldn't get enough heat into the filter to make the solder joint without removing the jumper wire from the circuit board trace. And of course the filter was sticking to my tweezers and I was having a real hard time keeping it where I needed it. Next time I think I'm going to solder mask the filter in position and harden it so that it can't go anywhere, and then I can solder to it, hopefully with better success. The hot air gun didn't really work that well in this situation. I was able to tack it down enough to where I could work with the filter jumper wires, but later I found out that I had to go back and manually resolder those pads. So now I'm just preparing the remaining little bit of a via to connect to, tinning it, putting the jumper wire in place. Fumbling around quite a bit, not as graceful as I would have liked. With the filter and jumper wires in place, I do some quick continuity checks to confirm everything's good. After confirming the solder connections, I go ahead and install some solder mask. I tried to get it around and on the filter in an attempt to secure it better to the board. Checking the cure of the solder mask and applying more solder mask up near the IC chip. It's amazing how a tiny microscopic, barely visible dot of solder mask looks like a river when you apply it under the microscope. With the most difficult part of the repair out of the way, now I focus on replacing the USB charge port. Right now I'm applying some low melt solder and using wick to try to open up the holes. I usually have a lot of trouble with this for some reason. I think that I need to heat the board up more with hot air before I try to use an iron and wick alone. Maybe using hot air and the iron together is going to be a better result. I've seen other technicians using solder sucking pistons to remove the solder, so I decided to try it and completely failed. It didn't work for me. Wicking away the lead-free solder and cleaning up the area in preparation for a new leaded solder. I could not get all of the solder out of the ground holes. I ended up just filling them with solder and dropping the port in as I heated it. Ideally, I like to have all of the mounting holes clear and set the port down flat to the board, verify it's in a good position before soldering it in place, but I haven't perfected the technique. Applying leaded solder to each of the pads, I'm trying to get a decent amount of solder so that I can ensure whenever I place the port that it will make a good solder connection. Using isopropyl alcohol and an ultrasonic toothbrush to clean up the area. Pre-tinning the new port pins, applying flux and solder to each pin carefully to not melt the plastic. I'm applying a layer of flux because we won't be able to access this once the port is in place, and this should help the solder flow onto the pins. I had difficulty determining when the solder was liquefied enough to place the port, so I got it way too hot. As you can see, I ended up melting the plastic pretty bad on this port. I could have made it work. I decided to go ahead and redo it. I don't have the footage for that, but I did it a second time and heated it from the bottom so as not to melt the plastic of the port. At this point in the repair, I thought that, having corrected the P13 IC chip and the bad solder joints and the filter replacement, that after the USB port was put in, I was done. Unfortunately, when I connected the mechanic tail insertion tester, I found that A6 and A7, B6 and B7 diode readings were too high. Amazingly, I was able to Google that, and AI said to check a filter, and it ended up being the issue. I had never seen this particular filter fail before, so I initially thought that, my port replacement had some kind of a problem there.